So far we've looked at static password files and static token files, and both of them are, as the name implies, static. So next up we want to look at OpenID Connect, and that is a separate identity provider, and it's not static anymore. So we don't have to restart the cluster or restart the API server in the cluster for it to update its configuration. And if you don't know what OpenID is, don't worry about it. In this video, I'll give you a very short introduction into what OpenID is and what components are involved. And it starts in the Kubernetes documentation here that has this great picture here, and I have this in a bit bigger here in full screen mode, where you can see how the identity flow works, and you'll learn something about what OpenID is and what OAuth2 is, which is the underlying protocol of OpenID. So it starts with a user that logs into the identity provider. Kubernetes is not involved here at all. What they get back is a set of tokens, an access token, an ID token, and a refresh token. Why there are 3 different tokens, don't worry about that for now. Just know that you get back a token, and this token proves A, who you are, and possibly B, also what you can do. So it contains authentication, possibly also authorization. With this token, you can then use kubectl. So you pass that token that you got back to kubectl. You can either use a token flag or you can save it into your kube config. And you can then use kubectl to talk to the API server. And notice that the API server now does not talk to the identity provider. And that is the cool thing about OpenAuth2 and OpenID Connect in general, that you don't have to have this runtime dependency to the identity provider. Basically, all you know is that the identity provider signed your token with their private key, and you have their public key because you retrieve it every once in a while. And with that public key, you can verify, was this token really issued by the identity provider? And if it is, that means you can basically trust all the information that is in there, even though you received it from the user themselves. And to do that, the API server now does a standard process of finding out whether this token is valid. First checking, is the signature valid? Because if the signature is not valid, that basically means all the other information doesn't matter at all because it could have been tampered with. But if the signature is valid, that means all the other information in this token can be trusted. So the next one is, has this token expired? So tokens have a limited lifetime. So you want to see, is this token still valid? If yes, then the next way is the user authorized? And that's not the focus of this video for now. We'll have other videos on authorization. For now, we care about, is the user authenticated? So we can skip that step here. If the user is authenticated, we can then do whatever action we were planning on do. So if this was a kubectl get pods, then we might now return the pods that the user queried, and then kubectl returns that to the user, even though that basically just means it prints it out to your console so that you can then read it. So far, I've mentioned 3 different components, so let's dive a bit more into detail about what those are. I've mentioned OAuth2, I've mentioned OpenID Connect, and I've also talked about a token or a JSON web token in more detail. So let's check out what these individual components mean and what they do. So OAuth2, so they say, is the industry standard protocol for authorization. So it's authorization. It doesn't really have authentication in it. It's basically just authorization. And it defines a couple of different grant flows. We'll see them later. This basically is, how do you retrieve this token? But it's all about the token itself. So there's also the JSON web token definition is in here. And this looks very familiar if you've seen definitions by the IETF before. So this is what that token looks like, and it's mostly standardized, and that's pretty cool because that means that different OpenID or different OAuth systems can talk to each other even though they don't really know of each other. The systems are really nicely decoupled, and the standard is defined here. So then there's also OpenID Connect, which builds on top of OAuth2. And OpenID Connect, they say, is a simple identity layer on top of the OAuth2 protocol. So where OAuth itself only does authorization, OpenID Connect then also provides authentication. And this is why Kubernetes uses OpenID Connect and not just OAuth2, because it really needs that identification components there. So now that we know what OAuth2 and OpenID Connect is, let's take a look at what it looks like. So this is one other thing that's provided by OpenID Connect. There's the OpenID Connect Discovery Standard, and this is a nice endpoint that is a well-known endpoint for a specific realm. Don't worry about what realms are for now. It's basically like namespaces in Kubernetes. And in this well-known URL here, there's everything that you need to know about what this specific OpenID provider supports. So basically, there's all the different URLs that you have to use for these grant flows, for example, for getting a token or for logging in, and it also shows what grants are what grant types are supported, what response types are supported, etc. So this is really, really convenient, because basically what that means is all we have to do is point Kubernetes to this single URL, and because this single URL has a well-known URL called OpenID configuration, all of this configuration can be retrieved completely automatically in the background. We don't have to configure any of that. So as I just said, this is coming from an identity provider. We haven't talked about identity providers at all yet, but in the world of Docker, it's super easy to spin one up, and we have one here. I've used Keycloak here. In the next video, I'll show you how to set this up, but basically for now, this is just a very simple identity provider that I've spun up and configured. And now let's take a look at what a token in here looks like. So for this, I've prepared something here. We're just doing a curl against this URL coming from that page, from the discovery page that we just saw. And we're setting the grant type to password and the client ID to a test client that I just created. This is a public client, so we don't need a client secret for it. And then I have a user defined in Keycloak that is called admin and has the password admin, and with that we get an access token, and this access token now has a specific validity. It expires in some time, and it also contains some information. So in order to inspect that, let us pipe that to pb copy to copy it to the clipboard, and then we can go back in our browser, and here in the next step, I've opened this handy little page called JWT.io, which inspects a token. And if I just paste this token, then I just copy it in here, then we see some nice syntax highlighting. There's 3 parts to this token. The first one is a header, and that's also decoded here separately on the side. And it basically says what algorithm is used to sign this, what type it is, and an ID that points to a specific key that it was signed with. The next part is then what is most interesting, because basically that is the payload that contains everything we might want to know. In this case, it has some authorization information that isn't too relevant for us right now, but also it has such simple stuff as the preferred username and also a subject, which is a unique identifier that identifies this admin user. The third part is then the signature, and the signature validates that the payload, or the header and the payload, was actually signed by a known authority, in this case our OpenID provider, this Keycloak here that has a private key. And if we have their public key, and we do have their public key because it's public, we can verify that this was actually sent by them. And that basically means that anyone can validate whether this token is valid or not. And how is the key retrieved? For that, we can just go back to this discovery page here, and there is also JWK. So this token here was a JWT, JSON Web Token, and here is also JWK, and JWK is JSON Web Keys. And what you have right here is basically a public key that is in a different format. You're usually used to the PEM format, I think, and this contains all the same information, and this can actually be converted into the PEM format, and then you would immediately recognize it as a public key. So I think we now have enough understanding of what the underlying system is, what OpenID Connect is, what OAuth2 is, and how we can use those tokens, and that should really be plenty to get started quickly. So in the next step, all we have to do is I'll show you how to set up this Keycloak client, and also how to configure it so that we can use it with Minikube. And then in the third step, we will integrate it with Minikube, retrieve a token, just how we've already done here, retrieve this token and use it to authenticate against the Minikube API server, and that should then work.